Okay.
Okay. So yes. Okay. So we had some discussion in the last class as well. Today we will just finish this chapter and talk about the questions, inshallah. Okay. Now let me just choose a color. Okay. Now properties and laws of sets. We did discuss some of these in previous class as well, but now we will discuss all of them together. Okay. The very first property is commutative property. So we have been studying the previous chapter in which we talked about semi-groups, monoids, and stuff like that. There I told you about commutative property, that A steric B equals B steric A. Okay. A commutative binary operation is such that A steric B equals B steric A. Okay. So just follow this over here. A union B equals B union A. This is going to hold every time either we write A first or B first, right? This should be clear. And A intersection B equals B intersection A. Obviously, for example, I have two sets, let's say A and B. This is A and this is B. If I'm saying A union B or B union A, every time what I'm trying to say is all this area. And when I say A intersection B or B intersection A, every time I'm just trying to talk about the intersection area, this central area, right? So order does not matter. And this is why it is called the commutative property. Okay. Remember that A minus B is not equal to B minus A in general. You know why? We discussed this minus sign, right? For example, let's say we have a set A and A has 1, 2, 3, and B has 3, 4, 5. Okay. And if I talk about A minus B, I told you in A minus B, we will have all the elements of A except those which are coming in B as well. And that is 3. Okay. So in A minus B, we will have elements of A and we will not write down those elements which we have in B as well. So this is what I will have for A minus B. And for B minus A, I am going to have every element of B except those which is in A as well. That again is 3. So I will have 4 and 5 only, right? So this is why, A minus B is not equal to B minus A in general. Okay. Now we have associative property. If I talk about associative property, again, this is how we define associative property in addition and multiplication. Like we used to say that A plus B plus C equals A plus B plus C. I will not be wasting time in proving all these, okay? I will certainly explain you the ones you will want me to, but some are very easy, okay? So I'll just pick up the difficult ones and explain. Right now, I'm talking about the easy ones because we have just started, and I don't want you to cover a lot on your own, but I will not explain every property in detail because some are very basic, right? And if you want me to, I certainly will. Don't worry about that, okay? So associative property, the way we define it for addition, for multiplication, this is how we are defining it for union and intersection, right? A union B, A union B union C equals A union B union C, right? And if we talk about intersection, let's talk about this. Let's talk about this one. So I'll rub this. Now we have 3 sets. I'll explain that using a Venn diagram. So let's say that we have a big universal set, although that is not needed, but still I'm just drawing it. And I have A, B, and C. This is A, This is B and this is C. A, B, and C. Let's talk about this side. A intersection B intersection C. First, we have to focus on B intersection C. So this is the set B, this is the set C, and their intersection is this one. And if I talk about A intersection, this yellow region, what would be the region? This would be the region, right? This is what we get. Okay. This is what I'm getting from the left side of the property. Let's talk about the right side using a separate diagram. So again, I have A, B, and C, and this time I will use orange. Okay. So A intersection B, A, B, and C. A intersection B will give me this orange area. And if I talk about A intersection B intersection C, the orange area is intersection with C, I will get this area. So using the left hand side and right hand side, I am getting the same area, right? So is this property understood? Yes, Sahib and Ahmed. Okay, right. So let's talk about the next one, distributivity of union over intersection. Okay, now this is a complicated term, but this is basically the distributive property over union and over intersection, which we have been doing for, addition and multiplication, right? That is, we know that A into B plus C is basically A multiplied by B plus A multiplied by C. Okay. So this is the distributive property which we have been using, and we can again prove it using the Venn diagrams and stuff like that. Okay. So do you want me to prove this and this, these two properties? Yes or no? Okay, I'll prove one. Let's talk about this one. Okay. Let's try proving this one, the second one. So let's do it quickly. Again, we have three sets and we have three sides. So let's say that this is A, B, and C. So we have A intersection B union C. This is A, this is B, and this is C. Okay. I will prove one side and I want you to prove the other side, and then we can compare the answers. Okay. Just so you guys can also practice things with me. So I have A intersection B union C. Let's focus on this. B union C means all this yellow region which I'm shading, right? This is B union C. And if I talk about its intersection with A, I am going to get this orange region, this region, right? Okay. So I am getting this orange region, and this is the left hand side of the property. I want you to check the right hand side, please. Check the right hand side and see if you're getting the same orange region or not. Okay. I'll give you 2 minutes.
Minutes for which question?
Yes, this side. Try making a Venn diagram for this one and just see if you're getting the same orange region or not. Okay.
Yeah, I'm getting the same.
Very good. And what about you, Ahmed? Are you getting the same region?
Okay. B union C
It is
will
A
share all
intersection
that orange.
A intersection B. It is A intersection B.
Distributive of intersection over union, right?
I am not getting what you are saying.
The question is the left hand side, right? A
And
intersection
this is the
B
left hand
union C.
side. This is the left hand side. I've proved that. I want you to prove the right hand side. Okay.
Okay, okay. Okay, one question. It is A intersection, whatever the answer, right? So shouldn't it be the only the middle part? Because that is
For which one?
intersecting
For
with the
this one? For the yes, it is the middle part.
left hand side.
It is only the orange part. This is what I'm telling you. It is only the orange part.
No. I'm talking the middle part, not the one which
No,
is
no. Okay, I'll tell you why. Okay, look. What is B union C? B union C is all the B and all the C, right? I'll state it again. It is all the B and all the C, right? All this orange region, okay? Think about it again. All this orange region is B union C. And if I talk about its intersection with A, I will get this. I will get this, okay?
okay.
And if we check it quickly for the right hand side, so we again have A, B, and C. So this time we have A intersection B. I will shade A intersection B using yellow. It says A, B, and C. A intersection B is this region. Then we have A intersection C. Okay, so A intersection C would be this region, right? And this as well. And if I talk about the union of yellow and blue, I am getting the same 8 region, right? I am getting this and this, okay? So you can prove any two sides using this strategy, and you will certainly get that both sides are equal, right? But obviously, when we are preparing, we are not going to prove every property. Yes, if you find any property very difficult, I certainly will, and I can, and even you guys would be able to. But from the exam point of view, I would want you guys to learn these directly, okay? The Morgan's laws, because this is very famous. The absorption laws, the idempotent laws, these are very famous. You have to learn them directly, okay? I would not advise you to, and I would never ever expect you guys would be able to learn every property. But yes, some of these, you have to memorize some of these because we'll be using them directly in questions, okay? So we did discuss the Morgan's laws last time. If I talk about the absorption law, this one, this is what we have, okay? So it is A intersection A union B. Although we have A union B here, but since it's just A intersection A union B, obviously we are going to get A union. And if I talk about the second one, we have A union A intersection B. So A intersection B will just have the common area of A and B, and this would be some part of A, right? This would be some part of A. A union some part of A will give me A only, right? Any confusions?
No, ma'am.
Okay. If I talk about idempotent, the first one is A union A equals A. Now, obviously, when we are talking about union, what do we say? We write down every element and we subtract it with the common ones, right? So A union A would have A plus A minus A, because A is the common region, right? A would be the common region. So this and this would be cancelled and we get A again, right? We did discuss this in the last class. Ahmed, are you able to understand all this?
Yes.
Okay. Let's talk about the complement laws. Okay, this is the first one. A intersection A complement. Now think about it using a Venn diagram. This is the universal set, and let's say this is A. If this is the A set, and if I am to shade A complement, obviously I am going to shade every part of the universal set except A, because I'm talking about A complement. So A intersection A complement is phi, okay? There's no intersection, nothing is in common. Obviously, I cannot shade anything because this is A, this is A, the orange part is A, and the yellow part is A complement. And I don't see orange and yellow together, right? This means that the intersection would be an empty set, and we denote it using this as well. Okay, this is a symbol of null set, empty set, whatever you call it. Is this understood?
Yes.
Okay.
Yes, ma'am.
Then we have A union A complement. Okay, again, the yellow part is A complement, the orange part is A. When I'm uniting both these, I am getting the universal set. So A union A complement is U. And I would not expect you guys to learn these this way, that this is the complement laws. No. You know the basic idea, that is more than enough. But yes, some theorems like the Morgan's laws and idempotent laws and stuff like that, you should remember those. Okay. If I talk about double complement law, what do we know? So obviously, what is A complement? A complement is the yellow part. And if I talk about the complement of A complement, so I will have everything other than A complement. That everything is A. I repeat, A complement is the yellow region. Okay, A complement is the yellow region that I have shaded already. If I talk about the complement of this yellow region, I will have everything in the universal set except the yellow region, and that is the orange region. That is A. So I will get A again. Okay. And if I talk about identity law, let's talk about the second one. A intersection phi, A intersection null set would be null set. Why? Because there's nothing in common, right? The only common thing is phi, empty set. So this is what I'm going to get. Is this understood? We have intersection sign, okay? We have intersection of two sets. One is a big set and one is an empty set. When I am trying to find out the intersection of a big set with an empty set, obviously nothing would be in common. So I will get the empty set back, right?
Yes, ma'am.
Mm.
Okay.
Okay, in the complement laws, can you show me the Venn diagram for the number 2?
This one?
Yes.
Okay, definitely. So, okay, I'll draw it again, okay? Although I can explain this using this as well, but let's try drawing a new one. So, since in this we have A complement and universal set, so I will draw this big square to represent the universal set, and this is how I denote it, okay? We only have A, this is the set A. Let's shade A complement using this green color. A complement is everything of the universal set except A. Everything of the universal set except the set A. And what is the other set? The other set is A. I will shade A using orange color. And now when I talk about the union of green and orange, I am getting the universal set. I am getting the universal set, right? This U is the universal set. Is this understood
Hmm.
now?
So use a universal set.
Yeah, U is the universal set.
Okay.
Okay. So let's talk about some more theorems. Okay. Now we have for any two sets, A and B. A and B are any two sets. Obviously, A would be a subset of A union B. In A union B, we have all the A and all the B. So certainly A would be the subset of this, and obviously B would also be the subset of A union B, right? Is this okay? This is A and this is B. This is A and this is B. When I say A union B, this means all this region, right? All this region has A and all this region has B. So I can certainly say that A and B both are the subsets of A union B, right?
Uh,
Right.
Please feel free to ask me. Please, okay? Don't be
can
shy.
you
If
like
you yes,
can you explain it again?
definitely I can. Okay, look. So for any two sets A and B, A is a subset of A union B. What do we understand by A union B? Okay, this is A and this is B. This is A and this is B. When I say A union B, I mean all of this set, right? So in all this shaded region, I have A. So definitely A would be a subset of A union B. And in all this shaded region, I have B as well. So B would be a subset of A union B, right? And if you're not able to understand it this way, we can think about it this way as well. So for example, imagine we have two sets. Look at this. We have A equals AB and we have a set B which has CD. When I say A, okay, and let me just write down something common as well. Let's say in B, I have B and C, okay? When I say A union B, what am I going to get? A, B, and C. I will not write down this B twice because it is coming in common, okay? I will have A, B, and C in A union B. So is A the subset of A union B? Yes, it is. The elements of A are A and B, and the elements of A union B are A, B, and C. So clearly A is a subset of A union B. And is B the subset of A union B? Yes, it certainly is. B has BC and A union B has BC. So this means that both these sets would be the subset of the big set which is being made using the union of the small sets, right?
Wait, so the A union B, I mean the B has the B and C, and A union B has A B C. So won't be B? Oh, B is the subset of A union B, right?
Yes, yes.
Oh, okay, okay, got it.
Okay, sure.
Yes, ma'am.
Okay, perfect. Just give me a second. My writing tablet is something is wrong with it. Just give me 1 second. Meanwhile, you can just have a look at all the properties. Okay, so let's talk about the second one. For any two sets A and B, A intersection B is a subset of A and B and A intersection B. Okay, fine. Now look. Again, you have two choices. Either you can understand these theorems using those Venn diagrams or using these sets. Which idea are you guys comfortable? Should I explain it using the Venn diagrams or using like these two sets? What do you think? Or both are fine?
Both are fine.
Okay. So let's say we have two sets A and B. This is A and this is B. And I am going to talk about A intersection B. This is the yellow region. Is A intersection B a subset of A? Yes, it certainly is. This yellow region is coming in A. This means that the yellow region, that is A intersection B would be a subset of A. And if I talk about this side, obviously this yellow region is coming in B as well. So A intersection B would be a subset of B as well, right? Is this okay?
Yes, ma'am.
Okay. Ahmad, are you able to understand everything?
Yes.
Okay. So we have let U be the universal set, then now U is the universal set, okay? U is the universal set. Let me just rub this. U is the universal set. This one. Universal set complement. What will we have in universal complement? Everything in the universal set except universal set, right? So all this region is the region of universal set, and in this complement or in this complement, we will have null set because there is no region in the universal set other than the universal set, right? Is this thing making sense to you? How do we define complement? Complement of any set is the area or the region or the elements of the universal set except the elements which we have in this set. If we're talking about the universal set complement, obviously we will not have any element. So it would be a null set. It would be an empty set. Okay. And if we talk about the second one, null set complement, it means that everything other than the null set. What is null set? Null set is nothing. Null set is just an empty set. Okay, it has no elements. So obviously, if we are taking complement of a set which has no element, we will get every element of the universal set. So in that case, we will have all the universal set, right? We will have all this region. Did you understand this?
Yes, ma'am.
Okay. Then wait. Okay. Then if we talk about the fourth one, A and B, A minus B equals A intersection B complement. Okay. Again, you can check that out. When I say A minus B, this means I will write down every element of A except that which is coming in B. For example, I don't need this square, so I'll just make two circles. Okay. So first, let's talk about the left hand side. Left hand side is basically A and B. Okay. This is A and this is B. In A minus B, I will have every element of A except that except those elements of A which I have in B as well. Okay. So obviously I will not write down these intersection elements. I will miss these. Okay. I will not write down these intersection elements and I will only have the yellow region. So yellow region would be the final region. And this is basically the left hand side. And if I talk about the right hand side, I will have two sets. I will have two sets, A and B. And this time around, I have to make the universal set as well because we are talking about complement. And in complement, we have everything of the universal set except that set, right? So A intersection B complement, let's just shade B complement first. B complement is going to have everything except B. And its intersection, the intersection of this yellow region with A will give me this part only, right? So the green part and the yellow part of this set, they are same. This is how we can prove the left and right hand sides of this equation. Did you understand this?
A minus B, like
Okay. In A
Yes.
minus B, I told
still
you, you will have
confused.
every element of A except the elements of A which you have in B as well. Okay.
Oh, okay.
So this is A minus B. Every element of A except those elements of A which are coming in B as well. So I only have the this region and not the blue region. Okay. Only this part of A and not the intersection part of A. Right? Is it okay with both of you?
Yes, ma'am.
Okay. So let's talk about the fifth one. For any two sets A and B, A, okay, this basically means if A is a subset of B, then this implies A intersection B equals A. Now, think about it yourself and tell me if you are able to understand it or not, okay? What is A subset of B? How would you write it down? That A would be in B, and then think about it and then see that if things make sense to you or not.
When all of the element belongs to B. Like there will be two circle, like a circle inside a
Yes,
circle.
excellent, very well, well done. Okay, that is the left hand side. Okay, and then see if that thing implies the right hand side.
A intersecting B, that will make whole of the A shaded.
Sorry, I missed what you were saying. Say it again, please.
Since A is intersecting B, so the whole region of the A will be shaded.
Okay, wait. Where is okay? So this is B and this is A. This is what Emma told me, and Zahib is saying that since it is A intersection B and A is inside B, so all region of A would be shaded. So this means that the intersection would be A only, right?
Yes, ma'am.
Very good. So fifth is clear. Think about sixth. Again, A is a subset of B. A is inside B, and we are saying A union B equals B. Do you guys agree? Again, the same
Yes,
situation,
ma'am.
but this time the
Yes.
union. Very good. Okay. Let's talk about the seventh one. For any two sets, A and B, A is a subset of B. Again, what do we have? And since we're talking about complements, so I will draw the universal set as well. Only then I would be able to understand it. So this is the universal set. This is B. This is A. This is the universal set. Let's talk about B complement. B complement would be everything in the set, in the universal set except B. So B complement is the yellow region. Okay. And what is A complement? A complement would be everything except A. So let me use the green color. So do you guys see that A complement has bigger region and B complement has a smaller region, and everything, every part, all the region of B complement is coming inside the region of A complement, right?
Yes, ma'am.
Mm.
Okay, this is clear. The eighth one, for any two sets A and B, A is a subset of B, implies A union B minus A equals B. Okay. Again, if we talk about this one, let me disrupt this big square. We don't need this. A is a subset of B means B is a big set and A is the small set. So I am going to get a big set, that is B, and a small set, that is A. This is A and this is B. And let me choose a different color. Okay, orange. Now talk about this side. A union B minus A. What do I have in B minus A? Everything of B except A, right? Except that part of B which is in A as well. Do you guys agree with this? Would I get this for B minus A, the orange region? What is B minus A? Everything of B except those elements of B which are coming in A as well, right? Yes or no?
Yes.
Okay. And A union this, what is A? A is this part. So if I unite all of this, what am I getting? I'm getting B, right? So this is how we prove this. Okay. I want you guys to prove 9th and 10th, okay, as homework. You certainly would be able to. If not, I'll prove them tomorrow. Let's talk about the next things which we have in this, okay? Okay. Now we have the 11th one. For any two sets A and B, okay, if we have two sets A and B, 1, 2, 3, 4, all these are going to hold, okay? So which one should I prove? Just tell me. Tell me anyone. Yes, please tell me.
Third one.
Okay. So again, we have the left hand side and we have the right hand side. If we talk about the left hand side, we have A minus B union B. What do we understand by A minus B? This is A and this is B. When I say A minus B, every element of A except those elements of A which are coming in B as well. So I will shade all the A except A intersection B. And what do I have? I have A minus B union B. So if I unite this with all the B, this is what I'm going to get. And what is this? This basically is A union B, right? Did you understand?
Yes, ma'am.
Okay.
Yes.
Okay, very good. Then would you please try proving 12 right now? Just try doing it. If A equals
Can
B,
you
yes.
can you do number one
Which one? Number one? Okay.
for
This
yeah,
one?
for 11?
Okay, okay, sure, sure.
Yes.
Right. So let's do number one. So we have again, this is the left hand side and this is the right hand side. Let's do the left hand side here. Two sets A and B. A and B. Left hand side is A minus B. Everything which I have in A except that which I have in B. Okay. All the contents of A except those contents which are coming in B as well. This is what I'll get for A minus B. Let's talk about the right hand side. For the right hand side, I have A minus A intersection B. Again, two sets A and B. A and B. And let me use a different color. So A intersection B is this yellow region. A minus A intersection B will give me every content, all the region of A except A intersection B. So everything that I have in A except the yellow part. So I'm getting the same thing, right? Both these are same. Did you understand it now?
Yes.
Okay. Can you try 12 right now, both of you, and tell me if you're able to do it or not?
I did.
Okay. So, and what about you, Ahmed?
Yes, it seems very
It seems what?
easy.
Okay. Very good. So let's talk about some more things. Okay. Now we have relation between set A and B. Okay. Now, if A intersection B is phi, what do we mean by this? A is a set and B is a set, and since
I
their
can follow.
intersection is an empty set, is a null set, I will not have any overlapping region, right? So if I talk about the second one first, what do I see? Elements in A intersection B would be 0. And if I talk about the first one, elements of A union B would be all the elements of A plus all the elements of B. If I had any overlapping region, I would have subtracted this two, right? But since there's no overlapping region, so I will only have this. Did you understand this?
Yeah.
And what about you, Ahmed?
Yes.
Okay. Again, as I told you for the first one, if A intersection B is not phi, which means that if A and B, they have something in common, number of elements in A union B would be calculated this way. Number of elements in A plus number of elements in B minus this, right? This should be clear. If I talk about the, let's say, fourth one, let's talk about fourth one. If B is a subset of A, right? Because like 3 and 4 both are same. The only difference is that they have swapped it. So if B is a subset of A, what do we see? Number of elements in A union B would be equal to the number of elements in A, because A is the big set, B is the small set. Number of elements in A union B is equal to the number of elements in A, right? And number of elements in A intersection B. A intersection B in this case would be this. So obviously we will only be having the elements of B. And if I have A minus B, what will I get? A minus B in this shape would again give me that donut kind of a thing, right? This is what I will have for A minus B. Everything, every part, all the region of A except that region of A which I have in B as well. Okay. And for this, I will have number of elements in A minus the number of elements in B, right? Is this obvious? Isn't this obvious? Number of elements in A would be all these. If I subtract the elements of B, I will again get my donut back. Do you understand it?
Yes.
Okay.
Yes, ma'am.
Okay. And again, if I talk about this one, number of elements in B minus A. What is B? B minus A means everything, all the elements of B except those elements of B which I have in A as well. Since B is a subset, B is in A. So obviously this will give me a null set. B minus A would be a null set. Number of elements in any null set are 0, right? So is this clear?
Yes, ma'am.
What is the purpose of the line?
Say it again.
What is the purpose of the line under the subset sign?
I did not understand.
B is subset of A.
Yes.
B is subset of A. There is a line
Yes.
under the sign.
Okay, this line.
What is the
You're
purpose of
talking
that?
about this. Okay, wait, I'll tell. Wait, give me a second. Okay, all right. So, if I am not misunderstanding your question, you asked me what is the purpose of this line, right? Basically, you're trying to say what is the difference in this and this, right? Am I correct?
Yes.
Okay. So, this is basically a proper subset. We discussed this, right? Do you remember proper subsets and improper subsets? Okay, I'll tell you. I told you in the last class how to define proper subset. Okay. Let's say if I have a set A and A has 1, 2, proper subsets of A would be proper subsets
Right. One to itself and one and two.
1, no, not 1, 2. Okay. Only 1, 2 and the null set. 1 to itself would be improper
Okay.
subset, right?
All right.
Okay, and the null set. You can either write it with this way or you can write it this way. Okay. And when we talk about improper subset, obviously this would be 1, 2. So when we have this line, it just means subset. We are not saying if it is a proper subset or if it is an improper subset, right? So, and if we talk about this one, it is certainly proper subset, right?
Yes.
So this means, this line means that either it is this situation or it is that A equals B and both sets are same, right? Either it is A equals B or it is A and B equal. I am not able to draw it this way, but let me try drawing B with a different color. This would be B, right? Did you understand this now?
Yes.
Okay. Okay. Now let's talk about the sixth one. Okay, let's talk about the sixth one. This should be clear, but if you are not able to understand this, I'll explain that again. But let's talk about the sixth one. If A and B are overlapping, if A and B are overlapping means they would not be disjoint. This is A and this is B. We will have some common region. Then this means that number of elements in A minus B, what would be the number of elements in A minus B? These elements equals number of elements in A minus the number of elements in A intersection B, right? Do you guys agree? Number of elements in all the A except the intersection region. And that basically is this orange shaded region, right? Is this understood?
Yes, ma'am.
Okay, Emma, did you understand this?
Yes.
Okay. And if I talk about the second one, what do I have? Number of elements in B minus A. When I say B minus A, again, this is A and this is B. It is the same thing. B minus A would have all these. So it would be number of elements in B, like all the B that would also have this intersection area, except the intersection area, just so we get the orange shaded region, right? Any questions so
Yes.
far?
No,
No.
ma'am.
Okay, perfect. Now this is the last thing which we need to discuss. Okay. All right. Now let's talk about this row. If we are talking about A union B, and if A and B are disjoint, obviously A and B would be two separate sets, right? And their union is going to have all of A and all of B. If we have some overlapping region, that is completely fine. Again, we will only have A and B. If A is a subset of B, this is how it will look like, that B is the big set, A is the smaller set, and A union B will have B, okay, because A is inside it. And if we talk about this one, where A is the biggest set and B is the smaller set, A union B will have A, okay? Because A is the biggest set. Is this okay?
Yes.
Okay. Let's talk about this row now. A minus B. When I'm saying A minus B, and if A and B are disjoint, it means that every element of A except those elements of A which I have in B. Since they are disjoint, there's no common region, I will have all the A. But if you talk about this one, where I have some common region, this common region, A minus B would mean every element of A except those elements of A which are coming in B as well. So I will only shade the black shaded part, which is shaded. Okay? U. Think about you and think about this third one and tell me if you are able to understand it or not. Okay?
Yes, but there won't be any. Because
Yes. Mm-hmm.
yes, because A is the subset of B.
Exactly. Okay, very good. And if we talk about the third one, last one, A minus B, A minus B, given that this time A is the bigger set, every element of A except those which I have in B, right? So this is the donut shape which I was making, and this would be the shaded region. Okay. So would you guys be able to do this row and this row on your own?
Yes, ma'am.
Yes.
Okay. Then let's talk about some questions. Okay. Let's talk about some questions. Are you able to see the questions?
Yes, ma'am.
Yes.
Okay, perfect. Just give me 1 second only.
I hope questions are this easy.
Say it again.
I said I hope questions are as easy as number one.
You have questions as easy as number one?
Yeah.
Okay.
Yeah, in paper.
All right. Okay. So the first question is, which one is not a set, right? We know what is the definition of set?
Yes.
Distinct and well-defined
None of the
objects.
elements.
So
Yes.
the elements should not repeat. And in the C option, we have
Yes.
4 coming 2 times, right? So C is not a set, right? Okay, let's talk about the second one. An element B of a set B can be written as, now B is the small element, it belongs to the set B. So how can we write this? Like
B
this,
is in
okay?
subset. An
No,
element,
I'll
yes,
tell
it
you why.
belongs.
I'll tell you why. Because,
No.
yes,
Because small b is not a set.
exactly. Okay, very good.
It's an element within the set B.
Yes. Okay, now let's talk about the third one. The union of all even integers and odd integers is, so we have even integers and we have odd integers, and when we are uniting those, what do we get?
The
Yes,
set of all integers.
very good. Okay, Zahib, are you able to understand these questions?
Yes, ma'am.
Okay, so we will get A. Let's talk about the fourth one.
Chitti?
Sorry.
I said Chitti.
Okay,
Ma'am,
in a
More
few
if
minutes.
questions?
Okay,
Okay.
so we have,
ma'am,
yes.
So how many chapters are done?
Who is this? Is this Zahib or Ahmad?
We both have questions, so if you can go
it was
first.
me.
Okay, so one question is how many chapters we have. So you can say that like we have, let's say 18 chapters, right? But
Have
we,
done, have done.
how many chapters we have done? This is the third chapter.
Okay.
Okay, but this is the third chapter. If you think about the total number of chapters is 25 chapters. Okay, like we have 18 back chapters, but in order to keep things simple, I have distributed them into parts, right? So you can think of them as 25 chapters, But please don't think about this that we have so many chapters which we need to cover. No, don't think like that. Some chapters are small, some are big. Now I have distributed trigonometry into 4 chapters, right? This is why we have so many chapters, just so things are understandable. Okay, and yes, what was your question, Zahir?
Right.
Oh, it was in the last question that if 0 was excluded, it would be the set of natural numbers, right?
No, no, I'll tell you why. Wait, well, that's a good question. No. Okay, so -2 is an even number, okay, and -3 is an odd number. So when we
Oh,
unite, okay, and in natural numbers we only have positive numbers.
yeah, I got it.
Okay,
I thought it was only positive.
no, no, no. Okay, so okay, this is the last question. So for today, so we have for any subset B of X, B union B is. Okay, now what do we understand? B is a subset of X, okay? X is the universal set. If I talk about B union B, what am I going to get? Think about it.
X?
This is X, okay? This is the universal set. Although, okay, let me write it down this way. Let me write it down this way because you guys might mix it up. This is a set X and B is the subset of X, okay?
Mhm.
So when I say B union B, what will I get? Obviously, B union
The
B would
intersection B.
very good, excellent, okay?
Null?
Not B Zahir, because we're talking about B union B,
Yeah.
right? That will give us this only. So we don't have X. That is why it would be D. Any questions? Anything that you have not understood?
No, ma'am.
Okay, so I'll stop sharing the screen and I'll stop the recording. And if you have any other questions, you can ask me.